All right, let's take a look at ratios and proportional relationships today. This will continue our accelerated mathematics first cluster as we will now examine our third learning target, which is going to focus on ratios in the real world. In today's instructional lesson, practice, and exit slip, you're going to take a look at some opportunities to apply ratios to the world around you. Predominantly or primarily what I'm wanting you to take a look at is how can you apply some of the techniques such as scaling up, scaling down, and unpacking word problems to build ratios to help you solve mathematical problems. Here's an opportunity where we can really scale both up and down in the same problem. The problem is that 2 donuts cost $1.50. The first two values that we have is 2 donuts cost $1.50. I could stop right there and take this bit of information and build a ratio, right? I know that 2 donuts cost $1.50. And so those two cost $1.50. But the question wants to know how much will 9 donuts cost. So now they're wanting to know how much 9 donuts will cost. Well, in this particular scenario, I'm going to need to scale down, and then I'm going to turn around and scale back up. Now, initially, I want to stop and go, well, if 2 costs $1.50, I need to find that unit cost. What is the unit rate of this? So on this, I need to find out, well, let's get that 2 because I want to know how much 1 donut costs. Remember, that's the number that I want to get to 1. I want to know what does 1 donut cost. So if I'm dividing to get from 2 to 1, that is a divide by 2, right? 2 divided by 2 equals 2, so therefore I must divide 150 by 2, which would give me 75 cents. So my unit cost is 1 donut cost 75 cents. And I've got my ratio here that tells me how much that unit is. But the question wants to know how much will 9 cost. And this is essentially, I'm scaling back up. Now I'm kind of coming at it going, well, now I need to know what would 9 of these cost me. How do I get from 1 to 9? Well, I'm multiplying that by 9. So I need to multiply my 75 cents times 9. Now I can always, and I encourage you to do this, step over to the side, multiply this out. 5 times 9 is 45. I regroup my 4. 7 times 9 is 63. Add my 4 into that, which would be my 67. I'm going to regroup 6. 0 times 9 is 0, but I've got my 6 up there hanging. I know that 9 donuts would cost me $6.75. This was an opportunity for me to, apply several layers from the first two learning targets, scaling up and down. In scaling down, I had to find that unit cost, but then I scaled back up. So, two-step problem in order to solve the problem. All right, so let's also, went too far. Let's take a look at where we're just going to see the relationship. This is just a scale or a table that's got a missing number. And in the missing number, we can see right here, I've got to be able to do something to fill that in. Now, what I want to focus on here is in this problem, I want to focus on the input and the output. I want to look at these numbers here and just look at them straight up and down, because when I start to look from left to right, it makes no sense what's going on. From 42 to 16 to 63 to 28. I don't see any type of pattern. So when I'm looking at this right now, left to right is no pattern. There's nothing that makes sense to me. But just because I don't see a pattern, I don't give up. What I need to start doing is looking from top to bottom. Now let's take a look here. The input is 42, then 36. What's the difference here? What just happened? Well, you see it's minus 6. 42 minus 6 equals 36. In fact, I could write an equation there on that, right? I could say right now 42 minus 6 equals 36. Then look at the same here. 16 minus 6 equals 10. See it? That's minus 6 as well. So we've got a minus 6, a minus 6. Let's test this over here. 28 minus 22 equals, look at me, I'm all backwards. It's 28 minus 6 equals 22. We see that minus 6 show up again. Oop. So we can assume, because they're all like that, 63 minus 6 is going to equal 57, and my missing number is 57. These input outputs, and what I know now is that I could do a couple different things here, but number one is these are still ratios. 43, they're 16 to 10, 63 to 57. I'm just looking at the ratios going vertically rather than horizontally. I see a pattern here. When I look at them up and down, there's a pattern, and the pattern is minus 6. Okay, so just a different way. It's a little more awkward, I think, as we're coming and we start thinking about X and Y coordinates, and some of that might confuse us. But the reality is, we could still plot. We could still plot these if we wanted to, and pull out a table, and it would just be all over the place and out of order. But we still see that relationship where there is a minus 6 between the input and output. So you won't see this that often. I do want you to just kind of take a look at it, and in terms of when you look at the table, don't always assume that you have to look this way here. Don't always assume when you get it and you give up and you frustrate yourself. Then stop, recalibrate yourself, and then look top to bottom and say, what is the relationship between these two numbers? And you might see that ratio and be able to detect a pattern. So that's a second way to look at it. Here's one way I want to actually stop and spend a little bit of time here. These are tables and graphs of ratios, and I'm going to make both a table and a graph here for you. It says for every 2 cups of ice, Mr. Elliott can make 4 milkshakes. So I want to stop here just for a second. Before we really dig into this, let's create a ratio. I know that 2 cups are going to give me 4 milkshakes. Now, what I want to do, let's stop, and can we agree that, well, then the unit here is going to be 1 cup of ice will give me 2 milkshakes, right? Because I divided here both sides by 2. And that's how I got that. Now let's make a table reflecting this. So up here, let's take a look at what are the 2 things I have. I have cups of ice, and then I have milkshakes, right? So in my table, and I'm going to zoom in a little bit, we'll put ice, and we will put milkshakes. Okay? Now I know that 1 cup of ice makes 2 milkshakes. I even put these are cups. And then I already knew that 2 cups gave me 4. Now look at the pattern here. Do you see the pattern? And we're going to get into this in just a second. We're going to call this as x plus 1. And we're going to say this is y plus 2. Why is that? Because when I look here, what happened when I went from here to here? This grew by 1. So if I put the previous number in and add 1 to it, it gives me the next number. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Now I come back here. Why? 4 plus 2, because I see that pattern. What happened when I went from here? Plus 2. 4 plus 2 is 6. and then 8, and then 10. All of a sudden, notice what I've got here. I've got an XY that I could possibly plot here. And so that's one way to make the graph. Then what I want to do is I'm going to come down here and I'm going to go back and forth, okay? But I'm going to come down here and on my XY, I'm calling X, and I've already set it up over here. X is my ice, right? This is my ice. Let me make sure my color's right. This is my ice, and this is in cups. And then that makes my Y is the number of milkshakes I can make. Okay? Now, my first ordered pair would be 1, 2 over 1, right? 1 cup of ice is going to give me 2 milkshakes. You see me? Then I go 2, 4. Then I go 3, 6, 4, 8, and then 5, 10. Then I can make a line there. It should be pretty straight. And in fact, that line, if you watch it, it would just keep going. We could take that and we've graphed the ratio. So notice the more ice I use, the more milkshakes. But then there is a, you could sit there and you could graph it on and say, hey, how many, you know? How much ice would it take me to make 20 milkshakes? You know, 20 is, let me make this small as possible. You know, this is my 20 mark. You know, what's it going to take me to hit there? You know, if I want to hit 20 milkshakes, what would it take? Well, if that line, now watch this. If that line, which started here, if I cross through all of those, right? And I think, did you notice I got off there? Let me try that one more time. I'm going to make a different color just in case it gets off. But it should. All right, there we go. And see that red line? That red line would just kind of, that's the ratio. If I keep to my 1 cup equals 2 milkshakes, that red line would tell me how much ice do I need. So what it's saying there, look here. In order to make 20 milkshakes, and the reason I'm doing, those are, you see this is 5, turn this off. Sorry. But this is 5, 10, 15, 20. And so that's 5, 10. It would take 10 cups of ice to make those 20 milkshakes. So there's a way that I can actually create a table and then graph my table so that I can see how that ratio plays out. And that line will give me, if I wanted to keep on going up, I can say how much ice to make 30 milkshakes or 40 milkshakes and so forth. Or vice versa, how many milkshakes will 15 cups of ice make? And that ratio, that's the way that it would play out. And so that's another great way using tables and graphs that you can use ratios. So that's going to be all for right now with ratios in the real world. Good luck with your learning target practice and your exit slip. Thanks for watching.